हेलो हेलो बच्चों। वेलकम फॉर फिजिक्स ग्रेड 10 ICSE for the chapter force point to point, content to content by Ganpati Sharma. Here, today we'll start grade 10 ICSE force. What is a force? What are the effects of force? Force is a physical cause which makes the body to move or a moving body to rest. It can change the direction, it can change the shape. The effects, what we can see in the sense in the pictures you would have seen, the ball which is moving, the boy is trying to apply the force and he's going to stop. By applying the force, the body can make it to move. Either it can make the body to rest or in motion. It can change the size or the shape of the body. By forces applied, you can change the shape of the body. You can see here in these two cases, it is changing or change in direction. Hockey stick, the ball, if you try to make the body to move, the stationary body will come to motion or motion to rest. Either of the case, these are the properties of force. What happens when a body is applied on a body? Body in the sense, we are trying to speak about something called rigid body. When a force is applied on an stationary rigid body, which has access to move easily, free to move, then it moves in an straight line path. It moves in a straight direction. The direction of the force you have applied, the body starts moving. This is called linear or translational motion. For example, on pushing a ball lying on a floor, it begins to move. Is an example of translational motion or linear motion. Suppose if the same body has an axis of rotation, what happens? The body starts rotating. When the force has been applied because of the pivot, what happened? The body starts rotating. The best example in our everyday life you would have seen in the doors, the hinges. It is an axis. The handle is given at one particular corner, exactly away from it, perpendicular distance, what we call it here. Longer the distance, the handle is given so that it is easy to move. If a force is applied on an rigid body which has axis to rotate, it starts it into an rotational force, which is called as moment of force. It's dependent on force into perpendicular distance from the point O. What is the SI unit of moment of force? Force is Newton, perpendicular distance is meter, SI unit is Newton meter. CGS unit is dyne centimeter. The CGS unit of force is dyne and perpendicular distance is centimeter. CGS unit is dyne centimeter. MCQs, be careful, the SI unit and the CGS units of moment of force, or it is also called torque, bacho. Yes, let's come to the factors which are going to affect the rotational of the body. It depends on the turning effect is dependent on two factors. One, magnitude, and the perpendicular distance or the line of action from the point of axis of rotation. These are the two factors on which the force of turning body is dependent. The torque is dependent on magnitude and direction. Let's move fast so that it will be a quick recap for us. Moment of force or torque. What exactly is? The moment of force is equal to the product of magnitude of the force and the perpendicular distance of line of action from the axis of rotation. Moment of force is dependent on force into perpendicular distance, that is F. O is the point of axis and P is the perpendicular distance, F into OP. The SI unit is Newton meter, CGS unit is dyne centimeter. For getting maximum turning effect, the question comes, bacho, where should be the force applied, or what should be the perpendicular distance? Any guesses? If perpendicular distance is larger, bigger, maximum, then you will get a more torque, means the rotation of the body will be easy. Maximum torque you can acquire by the magnitude of the force and the perpendicular distance. The few units, let us try to recollect it. SI unit is Newton meter, CGS unit is dyne centimeter, gravitationally SI unit is kgf meter, and CGS unit is gram centimeter. So when you are going to rotate, when an rigid body has the axis of rotation, in what direction can you rotate? When you are going to apply force it, when you are going to push it, what happens? You have two chances. One, either in clockwise direction or in anti-clockwise direction. The one which is anti-clockwise direction is called positive. If it is a clockwise direction, it is negative. Unit of moment of force, once again, 1 Newton meter, the smaller unit. What is a smaller unit of Newton? Dyne. Meter, centimeter, bacho. Newton means 10 raised to the power of 5. Centimeter, meter to centimeter, 10 raised to the power of 2. Bases are same, add it, 10 raised to the power of 7, dyne centimeter. 1 kgf into meter is 9.8 Newton meter. 1 gf centimeter is 980 dyne centimeter. In numericals, we require these unit and their relations. But so it's very important to know these relations for numerical point of view. Let us come back. Few examples of moment of force. The first one is the doors, hinges, axis of rotation, perpendicular distance. If more perpendicular distance, what happens? Sorry, it gain in torque will be more. Moment of force will be more. The other common example, moment of force, the upper circular stone of a hand floor grinder. You would have seen in the olden days what grannies used to do, or grind the floor, grind the corn or the wheat or the rice with this floor. Remember, bacho, here this it is the center, pivot point is the center one, and the axis of rotation lies on the perpendicular distance, very close to the circumference. So that kyo bacho, kyo the long handle is given at the last. The reason is perpendicular distance increases more torque. More torque means the work can be done easily. You can apply a small force and you can rotate it easily near its rim. The next example is of the same kind. A rivet, what you are seeing is an axis of rotation on the circumference. The handle is given very close to it. It is also an example of upper circular stone hand floor bacho. This definitely one question will come. Why it is being kept, or what is the purpose of this? Greater the perpendicular distance, more torque you are going to get it. Guys, students, you should be aware of this. Common example of moment of force. Another is what you call as steering wheel bacho. It is steering wheel. It is one is the fixed support, another the force you are going to apply on the either side, either from the left or the right hand, what you are going to apply. The rotation will be either in anti-clockwise or clockwise. Again, the perpendicular distance. I have a small doubt whether you know this or not. On what proportion the radius of the steering wheel will be made to that particular vehicle? Is the steering wheel of a car and the truck are the same? No. On what basis? Based on the ratio of the wheel, right? Based on that proportions, they have been the designed in that particular way. Can you replace this steering wheel for a truck, the car steering wheel to a truck? Nahi na bacho. Why? Because the driver has to rotate, keep rotating. The span of time is very less for him. Whereas a bigger one, if it is in the proportion of that tire, then it is easy for him. Nowadays, power steering is there. Even though power steering, he can rotate it easily. The span of time will be very less. Again, Bacho, you would have seen this example. You remember your tricycle? Three wheels, the cycle, what you have pedaled, and now what you are pedaling. Are the perpendicular distance from the axle to the foot are equal? Are the same? Naina? Bigger one has a longer perpendicular distance. Why? Why it is made in such a way that? Because the perpendicular distance increases, torque increases, bacho. Therefore, it increases. More torque. Therefore, it is given a longer one. And you cannot keep too longer. Why? You cannot pedal it. In certain proportions, are all these are being based on the tricycle, the perpendicular distance will be there. Based on this tire, this pedal is being made. Can you replace? No, you cannot replace. Keep that in mind. Yes, let's go with some more example. You would have seen mechanics using long handled spanner compared to the short one. What is the purpose of this, bacho? The reason is perpendicular distance increases, the torque will be more. He can rotate it easily, conveniently. Larger moment of force by a small applying. Force is also not so much. What happened? He can rotate the nut easily. Definitely 1-2 mark questions you will be getting. What is the conclusion of this moment of force? We conclude that it is dependent on magnitude. It does not depend only on magnitude. Of course, the force you have to apply, it also depends on the perpendicular distance. Larger the perpendicular distance, less is the force needed to turn. So you should be very clear with it. It is dependent on magnitude as well as perpendicular distance. These are the examples what you have. Oh, one picture has been repeated here. We'll try to change in the next slide. Yes, there is a concept called as couple. What do you mean by a couple? Try to understand. If it is a tap, this is a point A, this is a point B, two different points, the force are being applied in two opposite direction, right? Two different bodies, same force acting opposite to each other, then they're called as an couple. Rotation is always produced by the pair of force. Force of reaction at the pivot is equal to the magnitude but opposite in direction. Such pair is called as couple. Couple definition: two equal and opposite parallel forces not acting the same line forms a couple. A couple always need to produce an rotation. These are the examples where you can give. I'll come back once again before going concluding for one tap, 2 points, 2 forces, opposite direction, tightening the cap, 2 points, 2 forces, opposite in direction, lock and key, 2 points, rotation, opposite direction, steering wheel. But so all these are the examples of couple. Any example, couple formation. Once the couple is formed, what happens? Yes, it is rotation takes place. For rotation, couple formation is required. Thus, couple means two equal and opposite parallel forces not acting along the same straight line forms a couple. A couple is always needed to produce a rotation. If anything is rotating, bacho, then there will be an couple. In everyday life, we would have seen many things, but we would have not analyzed whether it is a couple or not. Yes, it is because of couple. Let us try to come back for a relation over here. Moment of couple, the perpendicular distance is d and two forces are being acted in opposite direction. Same forces, opposite direction, perpendicular distance. What is the torque at point A? and point B. What is the moment of force at the end of A? One terminal is end A, another is terminal B. Then force into OA. If one point is O, this is the center midpoint is O, and A, and the other side is B. What happened? It rotates in anti-clockwise. Moment of force at B. Again, it is F into OA. Total moment of couple will become force into perpendicular distance, and it is rotating in anti-clockwise direction. Anti-clockwise direction means positive. Moment of force is either force into perpendicular distance. The last concept we have something called equilibrium. What do you mean by an equilibrium, bacho? When number of forces acts on a body, the body produces no change in its state of linear or rotation motion is called equilibrium. Equilibrium is of two types. If it is at rest, it is called static equilibrium. When it is in motion, it is called dynamic equilibrium. Many forces acts. Everyday examples you would have seen. It is, these are the two. Let's try to come. What is static equilibrium? Remains stationary at rest is called as static equilibrium. Influence of several forces. The body is static. It is at rest only, bacho. That is called static equilibrium. You can see on a tabletop, a book is being kept on left and right. When force it, let us try to understand in opposite direction. Actually, diagram is in opposite. Let's get 30 newtons from the left side and 30 newton from the right side. What happened? The body remains such forces acting and equal forces. Concept is equal forces acting in opposite direction. The object remains stationary. But so what might happen if it is an unequal force? The force which has greater magnitude will move towards opposite to that particular, along that particular direction. If it is same thing happen vertically downward and vertically upward, and equal forces have been then the body is said to be at equilibrium. What type of equilibrium? Static equilibrium. Unknown quantity with known quantity. That is beam balance. Bacho, you would have observed it. Known quantity, unknown quantity, where the needle are exactly at the center. What happens? Till it comes equal, then we say that the weights are equal. Known weight with an unknown weight. It is an static equilibrium. But so let's go with the second type of equilibrium, dynamic equilibrium. What do you mean by a dynamic equilibrium? When a body remains in the same state of motion under the influence of several forces, the body is said to be dynamic equilibrium. If it is in motion, if it is in rotation. Example, raindrops. Once from the clouds, the droplets of the water are released. Number of forces acts, but it will net force acting on the drop on the water droplet is zero. Aeroplane moving, lifts, drag, thrust, weight, left, right, front, back, upward direction, downward direction remains constant. It has to balance it. Best example, a stone tied at the end of the string and drilled. What happened? It starts moving. Equilibrium, dynamic equilibrium. Bacho, you would have seen with Earth and the sun, planetary motion of the sun around it is an example of dynamic equilibrium. Motion of the electrons around the nucleus, electrons will be revolving around the nucleus is an example of dynamic equilibrium. All these are the types of equilibrium, bacho. Conditions of equilibrium. What are the two conditions of equilibrium? All forces acting on a body should be equal to 0, point number 1, and algebraic sum of the moments plus 5 minus 5 is equal to 0 should be 0. These are the two conditions of equilibrium. Exam point of view, very important, bacho. You should be knowing with two conditions. All forces, any number of forces, 0. Algebraic sum of those forces should also be 0, will be 0. Then only we say body is said to be at equilibrium. last one, the continuation of the same principle of moments. Principle tells us if a rigid support is being supported for an what do you call as a scale, meter scale, or an uniform rod of anything, then if you put the weight on one side and the another weight on to overcome it, it should be balanced. It that is, sum of anti-clockwise moments is equal to clockwise moments. This is the principle of movement. We have the verification also, bacho. Suspend a meter rule, weight of W1 and W2 on either side of the ruler. The meter ruler tilts one side. Now adjust the weight of the another one till it becomes horizontal. It should come. If you suspend to one side, what happened? It is going to lean on one side. To overcome it, you have to make it on the other side. The weight tends to turn to the meter clockwise, while the weight of W2 tends to turn the meter rule anti-clockwise. Clockwise and anti-clockwise. Beautiful example, bacho. You are able to see on the diagram that both are in opposite direction. What abstract we can come from this? Clockwise moments of W1 about the point O is W1 into L1, anti-clockwise W2 into L2. It is found that equilibrium W1 into L1 is equal to W2 into L2. That is, clockwise moments is equal to anti-clockwise moments. W1 L1 is equal to W2 L2. This is verifies the principle of moments, bacho. This is what the principle of moments. By this, part A, force concepts are over. They're still numerical and center of gravity. We'll try to meet in the next video, bacho. If you try to like our video, right, you can support, click what you call as bell icon, subscribe it, and you can contact me for any of the mathematics and physics doubts you have. Thank you, bacho. Have a nice day, nice time. Any doubts, feel comfortable to call us. Thanks for it. Thank you for everything.